Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is kth smallest prime fraction. So we are given an array which will represent all the numbers which are present in this particular array, and then those contains the one and then prime numbers, and then we are also given k number where it represents a integer, and then for every ij where I is less than j and then less than array length, we need to consider the fraction where array of I by array of j should be the fraction, and then we should consider all the fractions which can be built from I and then j, which will be the indexes of this particular array, and then we need to return the kth smallest fraction which can be considered by taking these two things. One is I and then one is j. So suppose let's say let's take this particular example where we have 1 2 3 5, and then we are given the k equal to 3. That means we need to return the k equal to 3, third smallest fraction which is present in this particular array, and then we need to build the fractions using this I and then j, and then I should not be equal to j, and then I should be always less than j. And then for this, if we consider the fractions, there is going to be n into n minus 1 by 2. Those are the different number of fractions that we can make, and then out of those we need to return the k equal to 3, the smallest fraction which we need to return. So for this, we are going to consider vector where it is going to store the fraction value which is going to be in the form of float, and then we are going to take the first element and the last element, which is going to be the first element is going to be numerator, and then second element is going to be denominator, and then we are going to take n equal to size, array dot size, and then we are going to run the two loops. First loop is going to pick the first index, and then second loop is going to pick the second index, and then we are going to find the float value, like the value of this particular numerator by denominator, and then we are going to get this fraction value, and then we are going to push with this fraction value with the elements which are present in this particular array, and then we are going to sort this, and then we are going to return the kth smallest element which is present in the array with the first numerator as our answer, and then denominator as the second element which is present in the array. For this, if we come to the time complexity, the time complexity is going to be big O of n square. Why? Because we are considering two loops, and then for sorting we are going to take log of n square. So this is going to be our sorting time complexity, and then we are going to have big O of n square as for building this particular array which is vector v, and then if we come to the time space complexity, we are going to take big O of n square. Yeah, that's all for this video. Thanks for watching the video.